All right, here we go. So solving equations with polynomial fractions. And I'll just say, remember from chapter 2, right? Way back when, if we had a problem like, say, x minus 2 over 3 plus 3/4 equals x over 6 minus 5. How would we go about solving this?
Find a common denominator.
And then,
Get both the fractions on that one side over the common denominator.
you could do that, and that's definitely one way, absolutely correct way to do it. However, there's a short way, an elegant way.
Equal 0?
No, I mean, maybe down the road, that's what would happen, maybe. But this is just linear. This is just an x to the 1, just an x to the 1.
Well, when you do one side, you can do the other side.
It's true.
Find the LCD and then times the entire thing by that.
Bam! Remember this, if we multiply by the LCD, all the fractions go away.
So put the 5 over 1 and then multiply it.
No over anything. All we say is, what's the LCD here? We find it. And what was it?
12.
It was 12. So if we get an LCD of 12 and we multiply everything by 12, we go times 12 times 12 times, I'll put it up first, 12 times, and you have to multiply even the whole things by it, then every single thing goes away. Cancel, cancel. We have 4 times x minus 2 plus cancel, cancel 4, 12 equals cancel, cancel 2x minus 60, okay? We're going to do that same process in this section. The only difference is the LCD we find won't be a number. It'll be a polynomial, okay? Okay, literally we're following those same steps, just the LCD will have variables. Okay, there's one new thing I will add, and I don't want it to confuse people, but sadly it probably will. Okay, so let's write out some general steps now.
So that's it.
So some general steps to solve an equation like this. I'm going to do an example next to it. Because I don't really have room, I'll do the example over here. Okay, here's my example, 32. So I would start with 2 over y minus, you know what, I'm going to do a different example. I chose this example, and I don't think it's a good example. I'm going to choose a different one. Okay. I did that example with the morning class, and I feel like it confused people more than it helped. So let me find a better example. Okay. Let's do one like 34. Okay, oh, instead of 32, 34, very close. Okay, so 34 is 2 over x minus 2 plus 4 over x equals 2. Okay, here's our problem. Okay, so let's write some general steps. Okay, step 1. Factor all the denominators, okay? That step's done, they're already factored, okay? As we get to more and more difficult problems, you will need to do more factoring. Okay, step 2. This is really the one new step here. In 7.1, when we were simplifying fractions for the first time, I mentioned that since we can't divide by 0, we need to explicitly write that, and we left that out of 7.1. now it's going to become important for one reason. Okay? We need to make a list. So we need make a list of restricted values. Okay, what I mean by this is okay, so what I mean by this is since you can't divide by 0, right away you need to say, I cannot have any denominator in this equation be 0. Okay, my answer cannot be one of those numbers. So let's do that really quick in green, and I'll do it in every problem in green. Okay, what would make my denominators equal to 0 here? Either, yeah.
X plus 2 equals 0?
Well, you just write x minus 2 equals 0, and then you would get
Yeah.
positive 2. So plus 2 plus 2, so you would say x equals 2, so x cannot be equal to 2. Okay? Or,
X equals 1.
no, because it's on the denominator, just x. We'd say x equals 0, so x cannot be 0. So right away, you say the denominator cannot be 0. So those two answers are not possible. If at the end of your problem, you get your answer as x equals 2, you say, nope, that's not possible, so we got no solutions here. We got one answer, and it was on our bad list, so no answer. Okay, so that's the new step right here. Other than that, what do you think our step number 3 should be? Do I need to, I'll just say, no, I'll leave it. Okay, so anyways, 3. What's that step going to be? How did we solve that first problem?
By LCD.
Yeah, and? You're right. And then? Once we have the LCD, what do? So what's the LCD here? What do you mean and? You said the word and, but yeah? Yeah, multiply. Okay, so the LCD is x times x minus 2. Okay, we did it, we got it. And then what do? Right, same step we did over here. We found the LCD was 12, and then?
Multiply everything.
Yeah.
By the LCD.
Exactly. Okay, so then multiply both sides of the equation by the LCD to get rid of all the fractions. And I'm just going to write, remember to distribute. Okay, so just remember that each numerator is already a group, so you have to actually distribute. Okay, I keep saying remember that because I don't want people to forget that. But let's continue this solving process. So I would multiply everything in my original problem, your step 4, by this x minus 2. Or I mean by the LCD. Okay? So here we go. Multiplying by the LCD. I'm going to do this step in green, so I'm alternating again. So I have times x minus 2. Times x minus 2 times x minus 2 Okay, so in the first one, what cancels? The x minus 2. Right, now there's no fraction. That's the whole thing we wanted. Right, from the second one, what cancels? The x. Now there's no fraction, just what we wanted, and nothing else cancels. So, moving over here, I'll write the last step over here. Wow, there's actually 2 steps. Okay, step 5 is solve the equation. So now we've got, just continuing this problem right next to it, this is 2x plus 4x minus 2 equals 2x x minus 2. I haven't multiplied anything out. All that happened was when I multiplied by my LCD, the denominators cancel out. I haven't multiplied anything out. Okay? So, how do I solve an equation in general, now that there's no fractions?
So you distribute 4.
Yeah, distribute everything, right? Yeah. Distribute the 4.
2x plus 4x.
2x plus 4x minus 8.
2x squared minus 4.
X. Yeah.
4x. Yeah.
Alright, next. It's always the first step is distribute, second step is?
Combine like
Yeah, combine like terms. Okay, so combine our like terms, we get.
6x.
Alright, now, what do you gotta remember when you solve an equation? Remember, you have 2 strategies.
Get variables on one side and variables on
Okay, one is linear. That's normal chapter 2 stuff, right? Right? In this one, as soon as you see an x squared, you're thinking strategy 2, which is polynomial. Right? How do we do that? First, first you gotta get it equal to 0. Remember, that's the big difference. When you get a polynomial, it isn't x's on one side, numbers on the other. We gotta move everything to one side, so it's equal to 0. That way when we factor it, we get a product equal to 0. And we can say either this thing must be 0 or this thing must be 0, because when we multiply them, they equal 0. Has to be equal to 0. So for a polynomial, move everything to one side equal to 0. And factor. Okay, that's our general strategy for every polynomial, and we saw the x squared there. So I'll move everything to one side, minus 6x plus 8, minus 6x plus 8. So we get 0 equals 2x squared minus 10x plus 8. Okay? And you guys are starting to see, every time we do a step, we move backwards in time a little bit, right? We were, at the beginning, doing a totally new thing we've never done, and then all of a sudden, after we multiply by the LCD, whoa, we're back a chapter. We're solving now a chapter 6 problem. Okay? Now we multiplied it out, we get to here, and now we're just factoring, right? We're factoring a polynomial. We've been doing that for a long time. First step in factoring, Nick, what do we do?
Find GCF.
Yeah, what's the GCF?
2.
Okay, so we find the GCF of 2, x squared minus 5x plus 4. Oh, that's nice. 3 terms and the lead coefficient's 1. Sweet. So how do we factor that in? Keep it going.
Do the x factor.
Yeah, what's the addition?
-5.
Yeah.
Positive 4.
Yeah, so we get?
So we get -4, -1.
Exactly. It's either 1 and 4 or 2 and 2. So it was -1, -4. So we get 0 equals 2 times x minus 1 times x minus 4. And so our last step is right, the whole reason
To see if it can be factored anymore.
well, so we did check, no factor anymore, we're done. And then,
X minus 1 equals 0.
yeah, either x minus 1 equals 0,
That's right.
X
Or-
minus 4.
or x minus 4 equals 0.
What about
Add
two?
1, add 1. You could say 2 equals 0, but 2 is never equal to 0. Another way to think about it is you could divide both sides of the equation by 2, and that goes away. So we're only looking at the variables. But you're right, we could set the whole product and say every piece of it is 0. Okay, so plus 4, we get x equals 4. So 2 possibilities. The last step is check to make sure none of your answers were restricted values from set 2. Or another way to think about that is or just plug them into the original equation. Okay, and I purposely chose a pretty hard problem. Okay, the LCD was a little complicated. There were 3 terms, each with a different denominator, and the solving was actually a polynomial, not a linear equation. So this had a little bit of everything. I wanted you to see that. Okay, I don't want that to be a big source of anxiety, because the problems start a lot easier than this. Okay, let's do a problem together that starts out easy. Alright, so starting out with 7, 6, the first problems would look something like this, okay? The first one with a variable on the bottom is number 6. Okay, number 6 is 1 minus 9 over x equals 4. Okay, so let's start. Factor the bottoms, done. Restricted values, what's my restricted value here? Yeah. X equals 0 would make the bottom 0, so right away we say x cannot be 0. In terms of our answers, we can definitely not have x equals 0. Okay, we find the LCD. What's the LCD?
One.
X times 1.
Well, yeah, numbers it would be 1, but then variables there's an x, right? But yeah, LCD of all these is numerically is 1, but then also x. So then what will we do?
Times x on the other third.
There we go, multiply the whole thing by the LCD, times x over 1, times x, and now our equation is x minus, this cancels, 9 equals 4x. Bam, no more fractions, right? Find the LCD and multiply by the LCD. No more fractions. And then this is linear, you just solve it like normal. Let's get all the x's to one side, so minus x, negative 9 equals 3x, divide by 3, divide by 3, x is negative 3, that's not, whoops, on this problem, that's not our restricted value, so that's our answer. Ooh, windy. We could also plug it back into the original and say, okay, let's just check. 1 minus 9 over negative 3 equals 4. 1 minus, this becomes negative 3. That's plus, so 1 plus 4 is 4, equals 4. Check, it does work. Okay, so we can always plug it back in. Alright? I want to leave that. That's some good instructions. Okay. Now let's do one that's a little harder. Alright, here's the problem I was originally going to give you with the instructions. So let's do 32. Alright, 32 is 2 over y minus 2 equals y over y minus 2 minus 2. Lots of y's, lots of 2's. Okay? First step, factor the bottom, done. Second step.
LCD?
That's third step.
Restrict number.
Yeah, right away we say, okay, y minus 2 equals 0. That would be when y is 2. So we'd say y cannot be 2 right away. Okay, we did that. And now, Frank, what's LCD?
Y minus 2.
That's it. And so what do?
Multiply by everything.
Yeah, multiply by y minus 2. We always put it over 1 if we're multiplying a fraction. Okay, so cancel, 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 and that was the whole thing canceling. So now our equation looks like this. 2 equals y minus this. Whoa, nice. Find the LCD, multiply by the LCD. Awesome. Okay, and then it's a linear equation. So when I distribute,
Negative 2y
Yeah.
plus 4.
plus, nice, because it's a negative 2 we're distributing. So y minus 2y plus 4. So 2 equals negative y plus 4. Then a minus 4 minus 4. I get negative y equals negative 2. Divide by negative 1, divide by negative 1. And we get y equals 2 as our answer.
Better than that, you restricted that.
Bam! But it doesn't work. So you might get there and just stop and say, I'm done. But that can't be your answer. And you think, why? That's so arbitrary. Well, let's plug it in. Let's see what we get. Plug in 2. We get, in the original equation, 2 over 0 equals 2 over 0 minus 2. That's nonsense. You can't divide by 0. So even though you got that as a solution, when you plugged it back in, it didn't work. The reason you got it as a solution, yet it isn't a solution, is think about what you did in your very first step. You multiplied by y minus 2. If y is 2, what did you multiply both sides by?
0.
By 0. And so no matter what the equation was, if you multiply both sides by 0, now it's 0 equals 0. And yeah, it would be a solution to that, because 0 is equal to 0. Right? So that was why this became nonsensical when you did that first step. So that's the one time, and this won't happen often, maybe 1 out of 10 times, maybe 1 out of 15 times. But be aware that you should, for sure, plug your answer back into the original, because most people will forget this step, and I'm not saying you should ignore it, but if you forget it, plugging your answer back into the original is a way for you to check, and if you get divided by 0, it's not an answer. So what would be the answer here?
No solution.
Yeah, no solution. You got one answer, and it's not a real answer, so you go, wait a second, and you write, there is no solution. Okay? Alright, so why did you one like that? Let's do one more. Okay, one last one. Maybe you'll have about 10 minutes to work on problems for this section. Let's do about as hard as it can get. This is about as hard as they can throw at you. Oh, yeah. Here's a curveball, okay? This is the last problem in this section. They think they can trick us, but they can't. 4 over y minus 2 minus 1 over 2 minus y equals 25 over y plus 6. Okay?
Factor out that 2 minus 1.
Exactly. First we factor. That's factored, that's factored. That looks factored, but actually it's negative y plus 2. So it's take out the GCF of negative 1, and you get, this is actually negative 1 y minus 2. Okay? So, what's the LCD here? Oh, sorry. See, I already forgot the step. What's our next step? Yeah, write those restricted values so you don't forget them. So right away, if this equals 0, we get y is 2. So y can't be 2, got it. If this is 0, and this is the same, y minus 2, so we don't need to check it again, but you can. If y plus 6 equals 0, minus 6 minus 6, we get y can't be negative 6. Okay, we got two restricted values. So what's our LCD?
Negative 1 times y minus 2. Is it all of it?
Plus, times y plus 6.
Times y plus 6. You gotta cancel out everything, right? So you do have a negative 1, you have a y minus 2, you have a y minus 2, but you were missing that y plus 6, so you gotta multiply by everything. Okay, and then what do?
Times LCD by everything.
Yeah, so times negative 1, y minus 2, y plus 6, times negative 1, y minus 2, y plus 6, times negative 1, y minus 2, y plus 6, all over 1, all over 1. Okay, so what cancels? In the first one,
Y minus 2.
yeah, so you're left with negative 4 y plus 6, okay, minus, what cancels this next one?
Negative 1 times y minus 2.
Yeah, so those two cancel, and we're left with minus y plus 6. Again, it's in parentheses. You can't forget you're subtracting the entire y plus 6, so there's parentheses there. Equals, and what cancels on the other side?
Y plus 6.
There we go. So we get negative 25. So find the LCD, multiply by the LCD.
So the middle fraction, how come that one doesn't have a y equals something, just like the first and the third one have?
Well, it was because I needed every factor, right? So I would say this equals 0 when y is 2. I would say this equals 0 too, and I would get the same thing because it's also y minus 2.
Even if it has a negative 1 on the side?
Yeah, because when is negative 1 going to equal 0, right? Because like, imagine I did negative 1 times y minus 2 equals 0. I'd say, well, either this equals 0 or this equals 0. So, okay, when does that equal 0? Plus 2 plus 2. Yeah. Yeah, good question. In general, what you're going to just look at is of the LCD is another way to do it. Is find LCD first, and then set this equals 0. So you're looking at each separate factor, when each factor is 0 of the LCD. Okay, and then it's just solve like normal. This is even going to be a linear equation. It's not even going to be a quadratic. So distributing in negative 4y minus 24 minus y minus 6 equals negative 25y plus 50. Combining my like terms, negative 5y minus 30, negative 25y plus 50. Put it all on one side. So I'm going to put the y's on this side so they're positive. So add 25y. Which then means I'm going to put the numbers on the other side, so plus 30. So this cancels and this cancels. And we get 20y equals 80. Divide by 20, divide by 20. We get y equals 4. Okay, is that one of our restricted values? No. And again, we could just plug it back in. And we would see 4 over 4 minus 2 is 2. Minus 1 over 2 minus 4 is negative 2. Equals 25 over, and then 4 plus 6 is 10. So we get 2 minus negative 1/2 equals, and I could reduce this to be 5/2. So I get 4 over 2 plus 1/2, or 5 over 2 equals 5 over 2. Check, it works. Okay, so that's where we'll leave off. So you guys have 10 minutes to practice this.